and we'll be doing chapter 3, squares and square roots. Okay, so in chapter 3, I know I have started in some classes, but for everyone, let's revise and let's start again from the same chapter, chapter 3, that is squares and square roots. Okay, and before we move on to square roots, we'll first do squares. Now, what do you mean by squares? Okay, most of you very well know what they mean by squares. Before this, we did exponents, isn't it? So, what do you mean by squares? Squares means when the power of the number is 2. Okay, so any number whose power is 2, we call it square. For example, if I write x to the power 2. So, x to the power 2, we can also read it as x squared. Okay, we can also read it as x squared. If I write 3 squared, if I write 3 to the power 2, what is the power of 3 here? It is 2. So instead of 3 to the power 2, what can I say and how can I read it? I can read it as 3 squared. Okay, instead of 3 to the power 2, I can say 3 squared. Similarly, 10 squared, a square, y square. So every time if you have any number whose power is 2, you can read that number as square of that number. So what does it mean actually? I said x squared, I said 3 squared, 10 squared, a squared, y squared. What does it mean? It means that the same number x is multiplied how many times? It means it is multiplied twice. So x squared means x into x. What does 3 square means? 3 into 3. What does 10 square means? 10 into 10. What does a square means? A into a. And what does y square means? Y into y. So how do we define square? Square of a number means the same number multiplied how many times? The same number multiplied twice. So if you multiply the same number 2 times, it is called square. So square in general, square basically means the same number is multiplied twice. The product of the same number how many times? 2 times. Okay, so this is what square means. And we'll come to square root later. Square root, okay, let me explain you this. Square root is the opposite of square. Square root is the opposite of square. And this square root we'll be doing later. For now, we'll be moving on to the square part. Okay, so now there is another term which is called perfect square. What term do we have there? Perfect square. Now what do you mean by perfect square? Okay, so any natural number is called a perfect square. Okay, it's called a perfect square if it is multiplied by another natural number. For example, 3 square. What is 3 square? It's 3 into 3. And how much do we get? 9. So what is 9? 9 is your perfect square. So 9 is called your perfect square. Another example, 2 square. What's 2 square? 2 into 2. And how much do we get? 4. So 4 is the perfect square. Because 4 is also a natural number and the square of 4 is actually 2 square. So 2 is also a natural number. So 4 is a perfect square. So give me, the other examples of perfect square are 36, 81, the same number multiplied twice. So 1 into 1 is 1, 2 into 2, 4. So 1, 4, 9, what else? 16, 25, 36, 49, 81, 100. All these are perfect squares. What about 21? 21 we get by multiplying 3 and 7. So do you call it a perfect square? No. It is not even a square. It is not a perfect square because you have to multiply what we have to multiply different natural numbers here. 3 and 7. Okay. And perfect square means the square of a natural number. The same natural number. 2 squares. So 2 into 2, 2 into 2. They are the same natural number. But 21 here is 3 and 7. So 21 is not a perfect square. 32. Which number gives you 32? 4 and 8. So 4 is a different natural number, 8 is a different natural number. So they do not make, they are not the same natural number. So 32 is not a perfect square number. So I hope you understood what a perfect square number. Perfect square numbers are the numbers which we get by multiplying the same natural number. Okay? It has to be multiplied by the same natural number, not by different numbers. Okay, and there are certain properties of perfect squares, but the properties we're going to be discussing in the next class. For now, moving on to exercise 3A. Okay, moving on to exercise 3A, page number 48. The first one, we will only be doing finding the square. So the question says, find the squares. Okay, find the squares. So the first one, I'll be doing 3 or 4 different sums like I do in the classroom. Okay, and the rest has to be done by the students. That is you people. So you'll have to do it yourself. The first one that we have here is number 1 is 15. So you have to find the square of 15. Now what does 15 square mean? It means 15 into 15. And what's 15 into 15? 15 into 15 is 625. Okay. The next number that I'm going to be doing is number 5, because number 5 we have 6, 3 upon 8 whole to the power 2. So 6, 3, 8 whole to the power 2. And I've chosen question number 5 because number 3 and number 4 are similar to question number 5. And if I do number 3 or number 4, you might be confused with number 5. Not everyone, but some of you might be. So I've chosen to do number 5. And if I do number 5, I'm pretty sure you'll be able to do number 3 and number 4 on your own. Now 638 is a mixed fraction. You can see it very well. Now this mixed fraction has to be first converted to the what? Improper fraction. And you know the process. So 6 multiplied with 8, it's 48 plus 3, we get 51 upon 8 goes to the power 2. And when you multiply this, what do we get? Which is 51 into 51 goes to the power 8 into 8. And what is 51 into 51? You can do it roughly over here, 51 and 51. You get 51 1. So you get 2601 upon 64. And the next one that we're going to be doing is number 7. So I'll be doing number 7 for you. Okay, number 7. What do we have in number 7? We have 1.1 whole square. And 1.1 whole square. What does 1.1 whole square means? It means 11 upon 10 whole square. So I've converted this decimal into fraction. So instead of decimal number, I'm doing it in terms of fraction. So 11. Okay, when you remove the decimal, how many digits is there after decimal? 1. So we have 10. And what is the square of 11? It's 11 into 11 upon 10 into 10. What's 11 into 11? 121. And what's 10 into 10? It's 100. And if we have to convert this in decimal, how many zeros do we have at the end? 2. So starting from your right hand side, you move towards your left. And how many steps? 2 steps. Because how many zeros do we have? 2. So 1, 2. So where will the decimal come? Between 1 and 2. So your answer is 1.21. Okay, and so we have different sums. And the last sum that we're going to be doing for today is number 8. Which is your 0.018 whole square. And what's your 0.18 upon 1, 2, 3 digit? It becomes 1018 upon 1000. And what's 18 by 1000 and 18 by 1000? Now 18 into 18. So when you multiply 18 into 18, how much do you get? You get 324 upon 1000. When you multiply, what do you get? 1000 into 1000 is 10 lakh. That means 3 zeros, 3 zeros. Altogether 6 zeros. And if you have to convert this in decimal, you know very well, there are 6 zeros. Starting from the left hand side, you count 1, 2, 3. Now the digits are over, so, but still continue. 1, 2, 3. And the blank space that you have, you will be replacing it with 0. So 0.000. 1, 2, 3. With 0, 0 and 324. That is 324. Okay, so this would be your answer. So the first one that we have, I'm going to write this as 225. I wrote it as 625. Okay, 15 into 15 is 225. 638 whole square equals to 51 by 8 whole square. So when you multiply 51 into 51, you get 2601. Then 1.1, when you square it, you get it as 1.21. And 0.018 whole square, when you multiply, you get it as 0.000324. If you don't want to convert these decimals into fraction, and if you are very much confident with the decimals and you can do the multiplication without making any mistake or any error, then you are more than welcome to do it directly without converting them into fractions. Okay? And please do the rectification over here. This is all I have for today. Please do stay safe. And the remaining sums which are there in the book, that is question number 1, finding the squares. I've done this many sums for you people. The remaining sums you'll have to do it yourself. Okay? That will be your homework. And you'll have to show it to me. You'll have to WhatsApp me those sums. Thank you, and I have a